All right, here is lesson 2 from Unit 0. We're going to start talking real quickly about separation of mixtures. So yesterday we talked about mixtures and the different types of mixtures, heterogeneous, homogeneous, etc. And honestly, this part right here, don't worry too much about this right now. We're going to talk about boiling things. We're going to talk about chromatography. We're going to talk about filtration later on, and once we get into more details here. So don't worry about how to separate a mixture right now. These are just kind of a very brief, hey, here's a few different ways you can take a mixture and separate it back into its normal substances. So okay, let's move on then to units of measurement. And these are two terms that you definitely want to be familiar with. If on the AP test or just in life, when they talk about the quantitative observations or they want you to do something quantitatively, it means that you're using numbers. It means you're doing some type of math. Okay, if you're doing, and so when I think about quantitative, I think about quantity. The quantity of something is how much or how many things you have. Whereas qualitative is talking about something but nothing dealing with numbers. So qualitative is like quality. What's the quality of something? Talk about something's color. You can talk about whether it's hot or it's cold. Okay, but qualitative has nothing to do with numbers at all. Okay, scientific notation. Now again, guys, remember this is Unit 0 is kind of a real quick review of regular chemistry. So I'm not going to go into a lot of detail about scientific notation. One of the things that I will tell you with scientific notation is sometimes they'll have numbers like this, like 3.2 times 10 to the minus third. And then they'll have like 1.28 times 10 to the minus second. And basically you have to compare those two numbers. Okay, and if you think about it, you might look at that and go, well, 3.2 is bigger than 1.28, so 3.2 times 10 to the minus third is a bigger number than 1.28 times 10 to the minus second. But if you take that and write that as a real number, 3.2 times 10 to the minus third is really 0.0032, and 1.28 times 10 to the minus second is really 0.0128. So you'll notice that actually this number, even though when written in scientific notation it looks smaller, this number is actually, if you take that number and you multiply it by 4, you actually get this number right here. So whenever those exponents change and you're not sure which number is bigger and which number is smaller, it can be really advantageous to write it back into standard notation, and then you can really look and go, well, clearly this second number is a larger number than that first number. Okay, and again, with scientific notation, that is something we will use periodically throughout the year. Not a ton of it, but you should absolutely be familiar with numbers that are written in scientific notation. And honestly, if you need a review of that, go on to YouTube and type in scientific notation and watch a video or two about it. Again, this is part of that's something you've got to do on your own time. Okay, we do use the metric system only in chemistry. We don't use inches, we don't use gallons, we don't use pounds. We use meters, millimeters, kilometers, centimeters. We use grams, milligrams, kilograms, etc. And we use liters for volume, milliliters, etc. Now, on the AP test, they are not going to tell you how to do conversions between them, but they also don't do a lot of conversions. But these are three that, again, in studying old AP tests, I've seen that are things that come up every now and then. And you look at, what the heck is NM? Who cares, right? If they give you something and they say something has a wavelength of 732 nm, and N does stand for nano, so that's a nanometer, and you want to put that into meters, you have to remember this conversion. So that will not be provided for you. So that's where you're going to go 1 times 10 to the 9th, nanometers on the bottom, 1 meter on the top. The nanometers cancel. So then in my calculator, I'm going to go 732 divided by, and then I'm going to make sure I put this in parentheses, 1 times 10 to the 9th. Okay? And if you do that, check that in your calculator real quick, you should get 7.32 times 10 to the minus 7th meters. Okay, so you should know that 1 meter does equal 100 centimeters, that 1 meter does equal 1,000 millimeters. And so if you have, for example, this one's pretty common. You have like 25.0 milliliters. But to do the math in the problem, you have to have it into liters. So the same conversion here. If 1 meter equals 1,000 millimeters, then we can say that 1 liter equals 1,000 milliliters. So you can do the conversion there, or you can go, 25 milliliters is, I just need to move that decimal point 3 spaces to the left, 0.025 liters. That's a real common conversion that you can do on the AP test. Okay, and now the question oftentimes comes up, well, how much work do I need to show? This is a free response question. How much work do I need to show? Anytime you're writing down a number that is not already on the screen, then you should show how you got that number. Okay, and by that I mean if they write 25 milliliters, you're okay to write 0.025 liters. You probably don't need to show that. But if they have 732 nanometers and somehow you come up with 7.32 times 10 to the minus 7th meters, you probably need to show that. Okay. Whenever you're in doubt, and again, having graded the AP test multiple times, there were many times where I had to take points off of the AP test, of the kids' AP test, because they had the right answer, but they didn't show their work. Okay, many times I've had to take points away. So always, when in doubt, always show your work. Okay, we don't use Fahrenheit, just like we don't use all of these other English things. There's no inches, there's no gallons, there's no pounds. We don't use Fahrenheit. We use Kelvin and we use Celsius. That's the only two that you will see on the AP test. The Kelvin scale, the nice thing about the Kelvin scale is the lowest temperature possible is absolute 0. So there are no negative Kelvin temperatures, which is really nice. And you have the same temperature increment, which means that if the Celsius temperature goes up by 5 degrees Celsius, then the Kelvin scale also goes up by 5 Kelvin. Okay, so whatever they do, they go up by the same amount. Okay, now what you need to know, and this is given on the test, I'll talk about that here in just a second. What you need to know is that whatever the temperature is in Celsius, you add 273, and that gets you the temperature in Kelvin. Okay, again, what I just talked about, when you calculate the change in the temperature, it doesn't matter what unit you're in. For example, we're going to learn an equation this year that looks like this. And that right there, that triangle with the T, you say that as delta. That is the Greek letter delta. So that's delta T, and that means the change in the temperature. Okay, and students many times like, well, is it the change in Celsius or the change in Kelvin? Again, if Celsius goes up by 5, Kelvin goes up by 5. So the change in the temperature does not matter whether you're in Celsius or Kelvin, because again, the change is the same. It's just the difference of this number 273. Okay, so that's one thing, is the change doesn't matter what unit you're in. Okay, another thing is that on the AP chemistry exam, you will be given what's called an equation sheet. So similar to what I give on tests in my regular chemistry class, you will be given an equation sheet that obviously is going to have a lot more equations on it than the equation sheet that we use in regular chemistry. Okay, and you will have that available to you every time you take a test throughout this year. So, and this conversion of Kelvin and Celsius is on that equation sheet. So sometimes I'm going to tell you, for example, you need to know how to convert between meters and nanometers. That is a no-brainer. Okay, and for some reason, they just don't put that on the equation sheet. Okay, this one, Kelvin and Celsius, they do put on the equation sheet, so that will be there. Okay, the next equation, also the density equation, this equation is also given on the equation sheet. Okay, and density is simply the mass of the object divided by the volume. Density equals m over v. Again, in my regular chemistry class, a lot of times we make this little triangle here. Okay, if you're trying to solve for density, basically you put your finger over the D and then you have mass over volume. If you're trying to find volume, how do you find it? You put your finger over V, and what's left is M over D. So when you find the volume, it's the mass divided by the density, and to find the mass, put your finger over the M, and that's density times volume. Again, the units are typically grams per milliliter or grams per cubic centimeter. And on the AP test, a lot of students ask, are units important? If they say include units with your answer, then units are very, very important. If they don't, then they're not important. Okay, which is actually kind of nice. Okay, just a couple more things here, and then we'll be done with today's lesson. There is the difference between accuracy and precision. So accuracy is how close you are to the correct value. So the density of water, the true density of water is 1. You do an experiment, you get a density of 0.986. That's pretty darn close to 1. So I would say that is an accurate. Your results are accurate. Okay. Precision has nothing to do with the correct value. Nothing at all. It only depends on, are your trials close to each other? So if you do 3 trials, and you get densities of 0.865, 0.872, and 0.859. All 3 of those are pretty close to each other. So you would say, yes, those measurements are precise. Okay, notice though that your data though is not accurate because 0.865, 0.872, and 0.859 aren't really that close to 1. Okay, and then the last thing you'll notice, it goes here, and then it keeps going here, and then it's calculations, blah, 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 blah. Okay, one of again, it does come up on the AP test, is the idea of significant figures. And significant figures is simply based on this idea right here, that your answer can only be as good as your worst measurement. Okay, and which means that the final answer must be rounded so that the answer reflects the accuracy of your measurements. Okay, so when you are doing a problem, when you get done with that problem and you're about to write your final answer, you need to think, okay, my answer can only be as good as my worst measurement. Okay, now again, what's your worst measurement? It depends. It depends, are you doing multiplication division or are you doing addition subtraction? And I'm going to give you a couple of examples here in a second. So here's a bunch of rules about when numbers are significant, when numbers are not significant. So again, any number that's not a 0, always significant. Okay, it's when zeros are in between or when you have zeros involved, that's when it depends on whether it's significant or not. So when dealing with zeros, again, here's kind of 4 different rules here that deal with zeros. But again, I don't want you to focus too much on this. This is not a big deal on the AP tests, okay? On the free response section of the AP test, one of the questions will be determined to be the significant figure question. It'll be the question that probably has the most math in it. And one of those, if you mess up on significant figures, they will take 1 point off for that. But that's it. So there's 1 point out of 100 on the AP tests that you can lose a point on for significant figures. So I don't want you to focus too much on that. Now, you might as well get the point and not lose it. However, I don't want you to worry. There's so many more important things with chemistry that involve real chemistry rather than how many digits go in your answer. Okay, so basically there's 2 times when zeros don't count. This is really all you need to know. If a number starts with zeros, right here, those zeros are not significant. Okay, that's one rule. Okay, the other rule is if a number ends with zeros and there's no decimal point, those zeros don't count. Okay, so we call these leading zeros. If a number starts with zeros, those lead the number. They're on the left-hand side of the number. Okay, those zeros are not significant. Okay, and trailing zeros, so leading zeros and trailing zeros without a decimal point are also not significant. Okay, so 2500, the way it's written, has 2 significant figures. Okay, the number 2500 with a decimal point, though, now has 4 significant figures. 2500 with a point and then a 0 afterwards now has 5. Okay, only if there's no decimal point, then those zeros at the end don't count. So many times, for example, you'll see them on the AP test, right? A 250 milliliter beaker, and they'll write 250, and they'll put a decimal point at the end like that. And the reason that they're doing that is to tell you that 0 is significant. This number has 3 significant figures. Okay, very, very common for them to do that. Okay, the number 0.0250, that number. Okay, that 0, again, that's a leading 0, just like here. So that 0 is not significant. Therefore, everything else after it is significant. So that has 3 significant figures. Okay, and that's really what you need to know. Just focus on those 2 rules. Leading zeros, not significant, and trailing zeros without a decimal point, not significant. Other than that, zeros are always significant. Other than those 2 exact scenarios, zeros are always significant. Now, how does that come into play? Because you're going to have to do calculations, okay? And when you multiply and divide, you look at your overall numbers. What numbers did you use to multiply and divide? Okay, and whichever one has the fewest total significant figures, that's what goes in your answer. So when you multiply, for example, 6.0 times 4.0, 6.0 has 2, 4.0 has 2, so your answer can have 2. So the answer is 24. Okay, but if you take the number 6 and you times it by 4, 6 only has 1 significant figure, so does 4. The answer should be 24, but your answer can only have 1 significant figure. Okay, which means the calculator answer 24 cannot be correct. How can I round that so that my number is close to 24, but only has 1 significant figure? Again, think about the number 0. Where can I put the number 0 in there to still be close to 24, but again, only have 1 significant figure? I make that 24 20 with no decimal point at the end, because remember, now that 0 is not significant. Okay? Now, with addition and subtraction, the rule is a little bit different. So with multiplication division, you look at all of the numbers you multiplied, whichever one has the fewest total significant figures, that's what goes in your answer. Okay? With addition and subtraction, though, you're looking to the digits to the right of the decimal points. Okay? So here's where you look at the number and you go, oh, this number, whichever one has the fewest number of digits to the right of the decimal point, that's how many go in your answer. So let's take, for example, 1.728, and we're going to subtract, I'm trying to remember, I'll pull up my calculator here. We're going to subtract 0.414. Okay? And then again, our calculator answer is 1.314. Okay? And then we look at that and go, oh, well, again, be very careful. This number has 3 numbers after the decimal point. So does this number. Okay? So therefore, my answer also should still have 3 numbers after the decimal point. This is actually a question that I graded a few years ago. Okay, and many students wrote the answer as 1.31. And unfortunately, I had to mark it wrong because I was told to by the AP people, because they looked at this and went, oh, well, 0.414 only has 3 significant figures, so my answer is only going to have 3 significant figures. And so they wrote that, and you couldn't award them the point. Okay, so with addition and subtraction, it's not the total number of significant figures, it's how many come after the decimal point. Okay, and so the answer to that would have to be 1.314, because both of the numbers up here have 3 digits after the decimal point, and then therefore so does my answer. Okay, your final answer to any calculation problem must have the correctly rounded number of significant figures. Again, not a huge deal if they don't. In a multi-step calculation, though, well, do I do the up part of it and then round it, and then do another part and then round it? No. Don't ever round until the very end. You can write numbers down that are rounded, but leave all numbers on the calculator in those intermediate steps and use those numbers to get the next step. Okay? Now, what happens if there's a problem that involves multiplication, division, and addition, subtraction? Well, then you've got a problem. Well, what rule do I use? Do I use multiplication, division, or do I use addition, subtraction? What you do is, if you switch in the middle, which you're going to probably end up doing, then you're going to have to use both rules. Okay, and by that I mean, let's say we're taking the number 36.0 and we're subtracting 3.0, and then we're dividing by 10.0. Okay, well, what's your first step? Well, clearly, you're going to have to subtract those numbers on the top before you divide. So 36.0 minus 3.0 is 33.0. Okay, now notice I'm about to switch rules. I'm going to switch to the division rule. So notice that I applied the addition subtraction rule there. They both have one number after the decimal point, and therefore so does my answer. And now I'm going to divide by 10.0, and now I'm going to use the division rule, which is this has three significant figures, this has three significant figures, so my answer needs to have three significant figures. The answer would be 3.30. Okay, but notice how easy it would be to go, oh, well, this only has two, so my answer can only have two. Nope, when you have to switch in the middle, that is, you absolutely have to take that into consideration when you're switching from one rule to the other. Okay, and that comes up a lot, and that's why I put this here. It comes up a lot with percent error. Now, towards the end of the year, I'm going to give you a document that's called Random Things to Remember. And the Random Things to Remember document is going to have, here's all of the equations that are not on the equation sheet that you should be familiar with. Okay? Now, percent error is, again, one of those ways to determine how good are my results. If you get a percent error of 0, that means that your results are perfect. Okay? If you don't, well, the farther away from 0 you get, the worse your measurements are. So this is an equation that is unfortunately not on the equation sheet, but you should be familiar with. Okay? And again, let's try to make this as easy as possible. The main thing here is you have to divide by the actual value. The top numbers, I always just take the bigger of the two numbers and subtract the smaller number. So then my answer isn't negative. Notice these absolute value lines here. Yeah, who really cares about those? Just take the big number minus the small number. So your top number is going to be positive, and then you have to divide by what the real value is, the actual value, to get the percent error. Okay, and it looks just like that problem right there. Okay, and then you multiply it by 100 to get a percent. Okay, now, what are some other ways that significant figures come up on the AP test is right here, this bullet point. When using lab materials such as a beaker, you may be asked if the instrument being used is good enough to give you a certain number of significant figures. Okay, for example, let's say you're measuring 50 milliliters of a liquid, and the beaker has a precision of, this is a plus minus 10. That means I can get close to 40, I can get close to 50, I can get close to 60, etc. But I can't say 45, I can't say 42, I can't say 53. So if it only has a precision of plus or minus 10, that means that this is the number that can change, not this number. Okay, so is the beaker precise enough for two significant figures? Absolutely not. Okay, because you can only measure it in 10 milliliter increments. Okay, what if you weigh something? What if you're going to put something on a balance and you're going to get its mass, and you know that it weighs less than a gram? That's an important part there, is it's definitely less than a gram, and the precision is only to 0.01 grams. Can three significant figures be determined in that case? Absolutely not, because you know that that first number is a 0, and that is not significant. And let's say it's, I don't know, 0.79 grams. Well, it doesn't matter. If the balance only has a precision out to 0.01, it means it's not going to give you any numbers past that second number. You're not going to get any numbers out here. So no, you can't determine three significant figures in that case. So you may see a free response question that may ask you, is this device, this beaker, this balance, this volumetric flask, whatever, is this good enough to go to this number of significant figures? And then of course you would say no, in this case it's not, because the precision of the balance only goes out 2 decimal places. You would need 3. Okay, and that is it for lesson 2.